Welcome to this very crowded morning talk. My name is Christoffer, and I'm a senior software engineer at K15t Software. And I'm going to talk about being ahead of your bugs. This is a scratch your own itch kind of presentation, because I got passion for developing software, but I got also passion for my little daughter, for playing guitar and playing basketball. But most of the time, those two have to disappear because I'm hunting for bugs. So I was looking for a tool to speed up my bug hunting. And at first I want to look at the existing K15t infrastructure that we use to develop our projects. We got, of course, many of the Atlassian tools. We use Confluence and our own scroll versions and scroll exporters for writing documentation and collaborating on documents. We're using Atlassian Jira for project tracking and management, for bug tracking. And we have Atlassian Stash and Bitbucket for source code versioning. We also introduced Atlassian Bamboo for continuous integration. And we have our own Sonarqube Nexus repository for managing releases and dependencies. And of course, with the Atlassian SDK, we use Apache Maven for building and configuration management. And as of now, we're almost all using IntelliJ as an IDE. And moreover, we also set up Crowd. So we have a single sign-on over all these applications. But for my concern, something was missing. And I found a new kit on our blog. It's called Sonarqube, and formerly known as Sonar. And it's a tool for managing and auditing software quality. It has three fundamental building blocks. It's about metrics about your project. It's about static analysis of your code, and it's also about dynamic analysis of your code. And all this is on the foundation of your code base, which is analyzed to generate metrics, to do this static analysis and also the dynamic analysis. And it's a web-based tool, and it gives you management views. So it's not only a tool for you and yourself, for a developer, but it's also a tool to make your management happy. So they can put numbers on their reports. But it's also a tool to make yourself happy, because from those management views, you can drill down directly to your code and find violations, find metrics that show you that you have problems with your quality or problems with your design. And moreover, you can use a history, so you will have historicized records of your analysis runs, and you can identify trends, and you can also set goals and see if you're diverging to this goal. A quick refresh: what's good software design? Of course, there are many definitions. That's a very simple one. It's called the SOLID principle. SOLID stands for single responsibility. That is your class doing one thing and it's really good at it? Is your class open for extension but closed for change? So do you have good encapsulation? List of substitution means, is your program still correct if you substitute one of your classes with a child class? Interface segregation means you should have small interfaces presenting a specialized view on the capabilities of your class. You shouldn't have a real big interface which is just a facade for your implementation, for this one implementation. And of course, there's dependency inversion, meaning that you should wire up your application using dependency inversion, making your application open for change and also easier to test. So why did I choose this solid principles? Because your metrics and your static analysis should help you discover flaws in your software quality. So let's have a look at metrics. The metrics that are collected are very basic. You have lines of comments, you have lines of code, you have statements, you have K complexity, that is how many branches do you have in your code. You have the response for class metric, which means how many method declarations and distinct method calls do you have in your class. This is an indicator if you might have a flaw in your single responsibility of your class, because if you have like 60, 80 or 150 distinct method calls, you're probably not doing one thing but many things. The same thing is the lack of cohesion of methods, which is an indicator that you have methods which have nothing in common, but they're in the same class, so that's lack of cohesion. And also duplications is a metric which is collected by Sonarqube, and this metric can not only be collected for your single project. So, for example, if you define the same string literal many times, there will be a typical duplication. But also it can be collected over your Sonarqube instance, that is between different projects. So you might really find possibilities for reuse. And for all the building blocks, you have this historic view. So you can always go back and compare how did this metric evolve over time. Okay, let's have a look at the static analysis. For static analysis, Sonar uses different tools. They are all well known and well established. It's Find Bugs, it's PMD, Sonar, and CheckStyle. So Sonar has some rules of their own. Again, you have the historic views to compare your static analysis. Did I maybe, when I changed the last class or implemented the last change, did I create new violations of rules? All of those tools let you select and configure those rules. So it's not making you happy out of the box, but you have to invest something here. That's the real work, and that's what we already started a few weeks ago here at K15t. So you have to choose and adapt those rules to match your software process. Because otherwise you will just have a number having like 1,000 violations in your project, but it doesn't tell you anything. Moreover, if you have conventions and guidelines, you should really try to have rules to check them, because otherwise they're worthless. If you don't check them automatically, you won't check them by hand. Okay, let's also have a look at the dynamic analysis. What does that mean? Well, for Sonar it simply means you can record your unit tests and integration tests. That is, it will display you the number of success and failures, and also the skip tests. But moreover, you can also record coverage, and not only for unit tests, but also for integration tests. So, and again, you have the historic views, and the coverage, of course, will tell you where you might have a lack of tests. Moreover, if you combine this with, for example, K complexity, you can say, if I have a high complexity but a low coverage, that's really probably going to be a problem in maintenance. Okay, now that's really the how-to part of this presentation. There will also be a blog post about that, so you don't have to jot down the code which will be shown in the live demonstration on the next part of the presentation. But the good news is you don't have to do much. There will be only minimal changes on the POM of your project. You will have to add some properties to your POM. You will have to add a profile which is about 100, 120 lines of XML in your POM to record coverage. Moreover, if you want to generate an analysis, all you do is make an install, then you have to do some flattening of your test reports for Sonar. That's bad news, but you can also do this with Maven and the dependency copy plugin or something like that. Or just a plain old bash script. Then you do Maven Sonar and skip the tests. That is a specialty of your Atlassian plugin, because the test infrastructure of the integration tests is rolling around by Atlassian, and so it's not supported by the Sonar tool out of the box. Attention. When you run your Sonarqube analysis, you will need a JDBC. You will need to have a JDBC access to the Sonarqube database. That means you probably will not do this on your own machine, but on some kind of continuous integration, maybe your Bamboo. Okay, now we'll have a hands-on and we'll look at the UI.